Hi, welcome to a video tutorial from NYBot. In this video we are going to find roots of polynomials using Texas Instruments, TI-84 plus CE and Python edition. We are going to find real and imaginary roots. We are going to use coefficients from list. We are going to save roots into the list. We are going to have a look at the polar and rectangular answer. This video is part of a full video of TI-84 plus CE Python edition. Link is below this video. TI-84 plus CE and Python edition. When we solve for polynomials, we can solve for roots. We can see the real and imaginary roots. We can get the angle if we use polar format, and we can solve up to degree 10 polynomials. If we set it to complex format, we can get the magnitude. We can convert from rectangular to polar and from polar to rectangular. So let's set our calculators to default so we have the same settings. Follow the screen. Second function M722, and it has been set to default. Press clear to exit. And if for some reason, if you press window or something, if you are stuck, press second function and quit to exit from that screen. When we talk about polar format, we have R, magnitude, and then theta, so this will be a circle rotating around circle. But if we have rectangular, then we have real and then imaginary part represented like this. And for the roots, for example, this is a quadratic and this is a second degree polynomial. The plot is crossing the x-axis or x-intercept, for example, at 3, and this is at -2, or in this case, this is x-intercept at 0.8, and then we have imaginary roots in here because this is a third degree. Let's go for example 1. We want to find the roots of this polynomial. Let's select up, follow this instruction on the screen, up, and then we select poly and and number 9, poly simultaneous 2, which is 9, and then 1. On this screen, we select order, the first line, we select the order. If it's not, let's go left and right, and must press enter to select it. And this is representing the highest order of the power, and the real have been selected in this area. So come down and then select rectangular format. This is a complex rectangular, and then we have complex polar. But we are going to select complex rectangular. It's blinking. It has not been selected. This has been selected. So press enter to select it. And it shows here at the top that we are in a complex mode. And in terms of representation or display format, it shows to be, and here the display format is auto. When you set it to auto, it shows a fraction. And if it's not possible, it shows decimal. So this is a good selection. And then for the normal, and then we have scientific notation or exponent or engineering. Go with the normal. You can select any number of floating point you want. And then radian or degree, we are going to go with the angle unit of degree. Radian is selected when you use sine, cosine, or other values. But in this case, we are going with degree, and then we go with the next. Every time we see the yellow background on the screen, it means we are using the buttons that are shown on the screen. In this case, next, we are pressing this button below the screen. And here we are going to enter the coefficients because we selected order 2 or second degree. We have the values. We just need to enter the coefficient. In this case, we have 6, and we press 6 and then enter. It has been moved. Now it says plus or minus this plus here. So we press plus for that and enter. After that we enter the value, in this case 1, enter. Now the cursor moved, the plus is now highlighted, in this case minus, we use this minus, and then enter, and then 2 and enter. Once everything is completed, press solve, and we get our answer x1 1/2, x2 -2/3. If you want to see the decimal value of this, press F and D, and we get the decimal value like this. Now let's store this to Y for plotting. We press store. After that, go down and then select this option, which is polynomial to Y, and press enter. It says polynomial stored to Y1. Now we press quit, and in this case main, and then 6, quit. Now we check the Y. If you check it, the equation that we entered have been brought here because we transferred it or stored it here. Now we can graph it. I'm not going to go with the details of graphing. I'm just showing you. Press graph and you will see your graph in here. And we can zoom in. Let's press zoom and then zoom in to enter so we can see it better. Now we can check zeros. I'm pressing second function calc and then 2 zeros. In this case I'm moving to the crossing point is the 0. I'm just going a little to the left, enter. Now it says go to the right bound. The arrow is here. I'm gonna go. I have separate video for this, so I'm not gonna talk about this. I'm just going on the right side of this line or the 0, and now it says guess. Now it tells us it's 0.5, which was the number that we get, and the other one was -0.6667. So if I do that and then 2 zeros, I go to the left and then to the right and then guess. Here the number that we solved. You can also view it on the graph like this. To quit, press second function and quit. Now app 9 1, next, solve. The values are here, and if you want to change the coefficients to something else, press coef or coefficient, and let's say you can change this to 5, and this one let's say -3 and +12 for example, and solve, and we got the value with real. So these two values are imaginary. You can see I at the end, which I'm going to give you the exact example too. To start a new polynomial, press mode, and then you can select a new degree from the screen. To exit, press main 6. Now example 2, this is now third degree, and these are the coefficients. This is -1 and this is -2 and then +3 +7. Let's press app 9 1, and in this case the order is 3. Let's move the order 3, press enter. That is the highest power, and after that let's select 3 floating points because we don't want a lot of values. So 3 decimal places, and press next. First one we enter -1. For the minus, here I enter minus and then 1 all together and enter. Then the highlight moves here. We enter -2. Now we enter minus. In this case, for these terms, we use this minus. For the first term, we use the minus at the bottom inside a parenthesis. Now the highlight is there. We just enter the symbol. In this case, it's minus, and then enter. The highlight moved. Now 2, and then enter. So for the symbol or sign, you press 1 enter, and then for the value, you press another enter. In this case, plus 3, so plus, and then enter, 3, and enter. Now for the 7, plus, enter, 7, enter. Now, once the 7 is there, then you can press solve, and we get the value, 3 x values, and first x is real, and that's 2 or imaginary value. Now in this case, if I press F and D, I cannot get a fraction because a calculator cannot do it, or it's not possible. Now if I press mode, we are in this screen, come down and change it to rectangular and enter. It is selected. Next, we are not changing the value, the same question, just press solve, and as you can see now it shows in a polar format 1.96, that is R, and that is the angle 165 degrees, depending on whatever value you set here. You see degree with I at the top. Now let's change it so you learn better. You see here it says the angle degree. Let's come down and select radian, and then next, and then solve. Now the value changed to 2.8. It was 100 and something. So this is now in radian and in polar format. Let's just change it back. Mode, come here, select rectangular, and then come here, select degree, and then main. I'm here. Now let's see how we can bring coefficients from list. Now we can get coefficients from a list. For example, this is our polynomial, and these are the coefficients. And the coefficients, if we extract them, 5 minus 3 to 11. Let's save these coefficients into list 1. I'm already in this screen. Press second function, quit, and then quit because I was there. Now press stat or statistics, and then 1. Now we are on the screen where the list is possible. We enter each value and then enter. So 5 and enter. Now minus 3, enter. As you can see, we got error. So press 2 to return, because we have to enter this minus 3 and enter. It worked. 2, enter, and then 11, enter. Now press second function and quit. We have the values in the list. Now let's go in step 3. Let's go apps 9 1. We are on this screen. Order is 3. It is 3 if not selected. That's the highest power, and then we selected the order, and then next, and then here we can select load. I'm pressing load, and we can bring L1 second function. When I press the blue, the second function, everywhere you see blue, those functions will be activated. So now, because I press the second function, you see the arrow shows. Now, unless L1 is in here, I'm pressing 1, it brings L1 and enter, and it brought all the values 5 minus 3 to 11. And now press solve. Here we solved it, 1 real and 2 repeated imaginary, and 2 values. 2 imaginary, one is minus, the other is plus with the I. Now let's see how we can save roots to a list. This time we are moving from here to a list. In this case, we want to do it in list 2. So press store, and then roots to list. Go once, twice, and then enter. It says which list. Press second function, and then L2 this time, and enter. Now it says all roots saved in non-real list, which means it is imaginary. Now press quit and then main 6. Now let's view list 2, press second function and then list. If I press this L2 and enter, here are the values. I went through the, if I press clear second function L2, directly bring it and enter. Here we see all the values separated with space inside the curly brace. The first value is real minus 1.0 plus 0i, which means this is real. It doesn't have imaginary value, but this arrow shows we have more. As long as we have the arrow, we have more values. And here this value, and let's see, it's imaginary and there is a space. And the next one, this is minus, perhaps the other is positive, plus, yes, it's the same value or different value, the same value with plus and imaginary. And we can use these values in our other calculation if needed. Thank you for watching. Please thumb up the video and also please don't forget to subscribe.